Hello everyone, welcome to Reactify Labs. Today we are going to learn communication protocols. Communication protocols. Okay, the things that are that I'm going to discuss today, um, some people must know or must have studied during their engineering. One of them is TCP, one is UDP, and there are a few more which you may or may not know already. But before jumping here, let's start from the basics. So, what is communication protocol or what are communication protocols? So, protocol means rule. As we say, you have to follow the protocol. That means there is a rule, there is a step that you need to follow for doing something. So, that's protocol. And what is communication protocol then? Communication protocol means if you have to do communication, you need to follow this protocol. For example, let's say you are in India and you know a language called Hindi. Let's say you have to talk to a person from Japan who knows a language Japanese. Then what happens in this case? It means a person from India needs to follow a certain protocol so that the person from Japan understands his or her mm, language or what that person meant to say. Similarly, a Japanese person needs to follow a set of protocols for communication so that Indian person understands what they are trying to say. So basically, what we are doing is we are establishing rules, a set of rules which need to be followed. Okay. I'm not talking about the rules now, but I'm going to talk about different kinds of protocols and where they are used. Okay. So I hope this clears it. What communication protocols are and why they are important. Okay, why they are important? Because similarly, just like an Indian does not know Japanese and a Japanese does not know Hindi, in the same way, different computers may not understand each other. Let's say one is Windows, one is Mac. They may not understand each other. Or let's say one is Windows, one is an Android phone. They may not understand each other. And let's say there is a website which is built in HTML and Android is trying to access it. They may not understand it, right? So for making this clear, for making devices understand each other or something over the network, we need to follow some kind of communication protocols. So HTML message need to be transformed in such a way so that Android can understand it over the internet or somewhere else. So that's what communication protocols are used for. Okay, great. Now now we know what communication protocols are. Let's go into our theory and understand the other remaining details or formalities about it. Okay, so let's start with the definition. What are communication protocols? So communication protocols are, these are essential for enabling, these are essential for enabling communication between devices over the internet. Between devices over the internet. They define the rules and conventions. They define the rules and conventions that devices must follow. So, rules and conventions, these are basically protocols. Like you must follow the protocol. For example, you are going to meet the prime minister. So, you must follow the protocols. You cannot just go and talk to that person, right? So, that's what devices also do. They define rules and conventions that devices must follow to exchange data reliably and efficiently. To exchange data reliably, and efficiently. Without these protocols, seamless and standardized communication across the web would be challenging. So that's why we need these protocols. Okay. So we have different layers and protocols for each layer. So let's first talk about transport layer protocols. For transport layer protocols, we have TCP and UDP. So what is TCP? We all must have studied it in our computer networks class. It's a reliable and connection oriented protocol suitable for applications requiring accurate data delivery. So we'll just write it down. A reliable and connection oriented protocol suitable for applications requiring accurate data delivery. Requiring accurate data delivery, such as HTTP based communication. Okay, such as HTTP based communication. In HTTP based communication, we cannot afford to lose any data. So that's why we need a reliable way. Next is UDP. It's a connectionless and lightweight protocol. Uh, Connectionless and it's a connectionless and lightweight protocol. It's ideal for scenarios where low latency is required. Okay, ideal for scenarios where low latency and quick data transmission are crucial. And quick data transmission are crucial. Okay, mostly they are used in like video games, not yeah, video games, video calls, things like these. Okay, video calls over the internet, because even if we lose some packets, that's fine. uh, we will talk more about TCP and UDP on how they operate, which one is how it's reliable, how UDP is not reliable. We'll talk about that very soon. So after transport layer protocols, we have something called application layer protocols. Application layer protocols. So what are the application layer protocols? One is server sent events. So server sent events facilitates real-time updates from the server to the client over a single HTTP connection, making it suitable for applications requiring live updates, like news websites, or let's say when you have to track cricket scores. When you open CrickBudge, you will see that the scores get constantly refreshed. With each passing ball, it gets refreshed, right? So that's server sent events. So it facilitates real-time updates from the server facilitates real-time updates from the server to the client over a single HTTP connection. Over a single HTTP connection, making it suitable for applications making it suitable for applications requiring live updates. applications requiring live updates, okay, like news websites, score tracking, anything. Second one is WebSocket. WebSocket is basically, it enables a full duplex communication between a client and a server, offering low latency, real-time interaction. It's commonly used in applications like instant messaging, when you do chat on WhatsApp. So that's WebSocket. Okay. So it enables full duplex communication. It enables a full duplex communication between a client and a server. Between a client and a server, offering low latency, real time interaction. I'll talk about more about these, how they work. Okay. So currently I'm just giving an overview of what the application layer protocols are. Another one is long polling. What is long polling? It's a technique where server holds a client request open until a new data is available. Means, let's say this is a client, this is a server. Client sends request to the server requesting a data. Server, if it has the data, it will send it. If it does not have the data, it will hold it. It will keep holding the request until it has the data. Let's say it has data at this point, then it will send the data. Okay. So this is what long polling is. The connection will remain open. The client does not need to periodically keep asking the server that if you have the data, if you have the data, if you have the data. Okay. It's a technique. It's a technique where server holds a client request open, where a server holds a client request open until new data is available. Until new data is available, providing a near real-time communication method. Providing a near real-time communication. What is near real-time? Near real-time is as soon as the data is there with the server, it's received by the client, as long as the connection is open. So it's a kind of near real-time. Generally used for, let's say, push notifications. Means our app is registered to the server that if any new notification comes in, just tell me. So the server will keep on holding the request. Once a notification comes, it will just send it to the client. Okay. So that's it. That's what long polling is. Great. Now let's talk about web communication. What is web communication? Web communication involves the exchange of data between two or more devices connected through the internet. Okay. Yes, we started with communication protocols, but what is communication? Web communication. It involves the exchange of data between it involves the exchange of data between two or more devices connected through the internet. Connected through the internet. Even if when we do WhatsApp group chats, it's still multiple devices connected through the internet, right? This exchange of information relies on protocols that define the rules for data formatting, transmission, and reception. Okay. So this this exchange of data that we are talking about, this exchange relies on protocols. We have different protocols. This exchange relies on protocols that define the rules for data formatting. that define the rules for data formatting, transmission, and reception. Data formatting, transmission, and reception. So, what protocols do? Protocols basically act as common language, ensuring that devices can understand and interpret the data exchanged. They provide a standardized way for different systems to communicate, promoting interoperability and reliability in the vast landscape of the internet. Okay, great. Now, let's talk about TCP in detail. So, TCP is a transport layer protocol, as we discussed, it's a connection oriented protocol. TCP is a transport layer connection oriented protocol that ensures reliable, ordered, and error checked delivery of the data between devices. That ensures reliable, ordered, and error checked delivery of data between devices. Okay. It establishes a connection, manages data flow, and guarantees that data is received correctly at the destination. So, what happens is, if data needs to be sent between A and B, A will send the data, B will send an acknowledgement. Okay, data is received. Then A will send one more act that okay, your acknowledgement is also received. So TCP is also called three-way handshake. So TCP follows three-way handshake to ensure that data is delivered. Let's say data get delivered, but this one could not come. Okay, actually start with this. Let's say okay, so let's say data could not go. In that case, what it will do is it will try to resend the data. Okay, what happens if the acknowledgement fails? If that okay, actually wait, I'm sorry, I need to go into more detail. So let's say this is A, this is B. When A sends data, let's say it fails, then in that case B will not receive the data and B will not send the acknowledgement. So no acknowledgement will come. Then A will know that something has gone wrong. So it will send the data again. Okay. Now let's say the data reached B. The data reached B and now B sent the acknowledgement and it got lost. A did not receive the acknowledgement yet, right? So it is possible that A will assume that data get lost and B will also assume that data his acknowledgement might get lost because it has not received the acknowledgement from A. Then A will wait, B will wait for some time, either A will wait or B will wait, depending on the timeout for each of them. So B will wait and after some time it will again send the data. Okay, it will again send the acknowledgement. So B will send the acknowledgement again. Now it's received by A. Now what A will do is A will send the acknowledgement that yes, your acknowledgement was also received. If it gets sent, very good. If it does not get sent, A will try to send again. Okay. And once this three-way handshake is complete, only then one data is sent that will be understood. Okay. So this is what TCP is, and that's how it guarantees that data is delivered. As long as these three steps are not completed, either A or B will keep on trying to send the data, which ensures that the packet is sent. Packet is well received by the receiver. Okay. So what are the benefits of TCP? One is reliability. TCP ensures that data is delivered accurately and in the correct order and retransmitting lost or corrupted packets. And next is it's connection oriented. What is connection oriented? It establishes a connection before data exchange, maintaining a reliable communication channel. So before data exchange happens between A and B, a connection will be established that okay, we are going to exchange our data. It's not that I'm going to send data to somebody else, anyone, and expecting an acknowledgement, right? What if I am not expecting a data? Why will I send an acknowledgement? It might be a scam or a corrupted data or a false link, something like that, right? So that's why a connection is established first, and then only data exchange takes place. Okay, great. Um, what are the examples? HTTP. HTTP relies on TCP, connection over HTTP. When you request a web page, your browser establishes a TCP connection with the server, and the server sends the requested page in a reliable manner. Okay, so whenever your web page is coming, whenever a web page is requested, there is a TCP connection because you want to get the entire web page. You cannot afford to lose any part of it. It might be a crucial part, right? So that's why TCP is used there. Great. Now let's talk about UDP. So in UDP, there is no guarantee like TCP. So UDP is a transport layer, connectionless and lightweight protocol. It's a transport layer. So it's a connectionless and lightweight protocol. As you can see, it's different from TCP. TCP was connection oriented. It's a connectionless. It's a connectionless and lightweight protocol that provides a fast but less reliable way to exchange data. Less reliable way to exchange data. As you can see, this was reliable, but TCP was reliable, but UDP was not reliable. Less reliable way to exchange data. It does not establish connection. Unlike TCP, UDP does not establish connection before transmitting data and is suitable for scenarios where speed is crucial, where we might afford to lose some data, but we need speed. For example, video call. When two people are talking on a video call, they don't care about whether 1 or 2 frames are not reaching or 10-20 frames are not reaching. That's fine. But what they want is a continuous non-interrupted service. They should be able to exchange their voice, exchange their image, however low possible. Okay, so it is connectionless. Since it is connectionless, it's it's free to do anything it wants. It just sends data. It does not expect any acknowledgement, which makes it fast also. So it's connectionless and it's lightweight. It's lightweight. It does not have too many packets. It has lower overhead and is more efficient in quick data transfer. Okay, so the best example would be that video call that we do over WhatsApp, or when we play games. Even when we play games, it is possible that some frames might not reach, so that's fine. Okay, great. Now let's talk about some application layer protocols in detail. So first one was SSE. First one is SSE, server sentiments. So it's an application layer protocol. It enables the servers to push real-time updates to the client over a single HTTP connection. Okay. As we have discussed this earlier, SSE is typically built on top of TCP. It's built on top of TCP. Okay. So what happens is there is a client and there is a server. So client just registers with the server. So first step, only one step client needs to do, it registers with the server. Then as soon as the server has updates, it will keep on sending to the client. Server will keep on sending to the client. For example, you registered for getting a notification of something, or you registered for getting let's say live updates of the news. So it means you registered to that news website and the news will keep on coming to you. So that's what SSE is. SSE is established over a traditional HTTP connection, and it maintains a persistent connection for real-time updates. Okay, imagine a news website that uses SSE to provide users with live updates on breaking news. SSE allows the server to push updates to the client as soon as new information is available, and thus creating a dynamic and engaging user experience. Okay, So what are the advantages? Advantages of SSE include being lightweight. If it's lightweight, it's fast. It is simple to implement. It is simple to implement and operates over HTTP. Operates over HTTP. Okay. What are the use cases for SSE? So use cases would be applications requiring real-time live updates. Applications requiring real-time updates like live sports scores, financial market changes. We need to know what the price of a current particular stock is at that moment, right? So for that we need SSE. Financial market changes. Similarly, social media feeds. Social media feeds. You might have noticed that while scrolling Facebook, as you keep scrolling, below you see that okay, there is something which has been posted just now. It means as soon as it got posted, it's delivered to your feed. So that's it. That's all about SSE. Now let's talk about WebSockets. So WebSocket. It's also an application layer protocol. It enables full duplex communication between a client and server. It is also typically built on top of TCP. Built on top of TCP. Okay, not TCP exactly, it's built on top of TCP so that a reliability can be ensured. So WebSocket connections begin with a handshake over TCP and then upgrade to WebSocket connection. So handshake happens over TCP and then it gets upgraded to WebSocket because now it knows that okay, TCP connection established, so we will not lose our data, and that's why it is said that it's built on top of TCP. It typically uses a persistent TCP connection for ongoing connection. What? Persistent TCP connection. So once TCP connection is established, it will remain persistent as long as the connection is open. So as long as two people need to talk, so the connection will remain open. And once they decide to, like one of them decides to drop off, the connection will be ended. Okay. So what are its features? It is basically full duplex. It's full duplex. In SSE, it was a server who was sending the message. Client could not send the message to server. But here, both client and server can send the message, or both peers can send the message to each other. It's full duplex. Similarly, it's low latency as well because we get the data quickly. It provides low latency communication channel, making it suitable for real-time applications. And full duplex because it enables simultaneous two-way communication, allowing both the client and server to send messages. And these are commonly used in chat applications where users can send and receive messages instantly, creating a seamless and interactive chatting experience. So basically what happens is, so there is a client, there is a server, there is a client. Client sends the message to server, server sends it to this client. This client sends the message to server, this sends to client. So basically it's not a WebSocket connection between two clients, it's a WebSocket connection between client and server. Each client is connected to the server. Okay. So now that is done, let's talk about the advantages. So what are the advantages of WebSockets? Low latency, efficient communication, real-time updates. Real-time updates, efficient communication, right? Great. Now, what are the use cases? So use cases, they are suitable for applications requiring instant data transmission. So we need instant data transmission, like chat applications, chat apps, right? So that's all there is to WebSocket. Now let's talk about long polling. What is long polling? So long polling is a technique where client sends a request to the server and server holds the request open until new data is available. Okay, as I explained before also, there is a client, there is a server. Client sends the data to the server. What's the difference between this and server sent event? So in server sent event, what happens is client registers with the server and then server keeps on sending it the data, right? But here this is not the case. Here client requests the server for the data. Once server has the data available, server sends it to client and then connection is closed. Again client needs to open the connection with the server to get the data. And once again when the server has the data, server sends it to the client. Okay. So this is what long polling is. And once data is available, server responds and the client immediately sends a new request. Client sends the new request again. Long polling is typically built on top of HTTP and operates over TCP. Long polling involves opening a new HTTP connection each time clients want to check the updates. Okay. Each time client checks updates, हर बार client जब update check करेगा, then this long polling needs to open a new HTTP connection. Long polling needs to open a new connection. Okay. So what are the use cases? Use cases are you generally push notifications. Push notifications in social media platforms. Whenever user receives a new message or notification, server can push the update to the client using long polling. It can be a kind of server sent event also. It can be a kind of long polling also, depending on how it's implemented. Okay, great. What is the advantage of it? So as you see, what happens is client gets the information in near real time. Near real time updates. So as soon as the data is available with the server, it sends to the client. And if not, then the connection remains open. It means no frequent communication. No frequent communication overhead. Why? Because client just sends the request to the server and forgets about it. If the server does not have the data at the moment, the connection still remains open. The client does not need to periodically pull the server of the information. So that's why the overhead is reduced or it's not there. Great. Now that we have talked about all these, let's talk about a few more things. One is MQTT, which is message queuing telemetry transport. So what is MQTT? MQTT is a lightweight open source messaging protocol designed for efficient communication between devices with low bandwidth and high latency conditions. Let me write it down. It's a lightweight open source messaging protocol. Lightweight open source. Lightweight open source messaging protocol designed for efficient communication between devices with low bandwidth and high latency conditions. It is commonly used in scenarios where a reliable and lightweight messaging protocol is used. What kind of messaging protocol? Reliable and lightweight messaging protocol is used. MQTT also typically operates over TCP or WebSocket connections, ensuring reliable and ordered delivery of messages. Okay, so the features of MQTT is again lightweight. MQTT is designed to be efficient and lightweight, making it suitable for devices with limited resources. MQTT follows a publish subscribe model. It follows a publish subscribe model. It operates on a publish subscribe model where devices can publish messages to specific topics and other devices can subscribe to those topics to receive the messages. Okay, so there is a publisher, there are subscribers, and they all register to it. And once the data is available, it will update all the subscribers. Okay, so MQTT is widely used in IoT for communication between smart devices. Let's say you have a fridge at home, there is a TV, there is a doorbell, there is something else, there are lights, something. So communication between them takes place using MQTT. Okay. Uh, okay, right. So just to reiterate it, IoT devices in smart home can use MQTT to publish data to a central server, and other devices can subscribe to receive these updates depending on what kind of data which one wants. So those updates can be received. Let's say for example, your phone has subscribed to know when your refrigerator is, let's say, empty. So what refrigerator does is it sends the data to the server that yes, now it is empty or it's going out of stock from vegetables. So this server will then update to the mobile phone that yes, your refrigerator is now almost empty, just go buy some groceries. Okay, so now that MQTT is also done, let's talk about two more things quickly in like short. One is COAP, which is called Constraint Application Protocol. Constrained Application Protocol. What is COAP? It's a lightweight application protocol designed for constrained devices in low power lossy networks. It is specifically tailored for devices with limited processing power and memory, the devices which have very low processing power. Okay, so it's a lightweight application layer protocol. It's a lightweight application layer protocol designed for constrained devices in a low power lossy network. It is specifically tailored for devices which have limited processing power and memory. So COAP typically operates over UDP. It operates over UDP, which is well suited for constrained devices due to its lightweight nature. Constrained access protocol is optimized for use in constrained environments such as smart homes or industrial IoT, where devices may have limited resources and operate in low power networks. Okay, in smart home, let's say example is smart home environment. Constrained application protocol can be used for communication between devices like, let's say, lights, sensors, thermostats. Communication between them takes place using constrained application protocol. COAP's efficiency makes it suitable for low power devices in these scenarios. Okay, so just one more thing I would like to talk about, which is gRPC. RPC stands for remote procedure call and G stands for Google because Google made it. So it's remote procedure call. So gRPC, what is gRPC? It's an open source high performance RPC. Okay, open source high performance RPC. RPC we all have studied in operating systems. So gRPC is an open source high performance RPC developed by Google. It enables efficient communication between distributed systems and is often used for building microservices architectures. gRPC typically uses HTTP2 as the underlying transport protocol, providing features like multiplexing and header compression for efficient communication. The advantages of gRPC is high performance. gRPC is known for its speed and efficiency thanks to its use of HTTP2 for transport and protocol buffers for serialization. Also, it is language agnostic. So it supports multiple programming languages, allowing different services to be implemented in different languages. gRPC is commonly used in microservices architectures for communication between different services. Each microservice can define its interface using protocol buffers, and gRPC facilitates communication between these services. So let's say there are different microservices. Let's take an example of Amazon. So there is a search service. Okay, Amazon's shopping app. There is a search service. There is filter service, or no, let's say there is um, add to cart service. There is a payment service. There is a notification service. So these services need to talk to each other, and gRPC can be best suited for them to talk to each other because each service can be implemented in their own languages. Let's say it's Java, it's Python, it's something else, it's something else. Still, they need to talk to each other. So gRPC is commonly used in these microservices architectures for communication between different services. Each microservice can define its interface. Each microservice will define their own interface. And gRPC, it's the responsibility of the gRPC to facilitate communication between these microservices. So that's it. And this concludes this communication protocols uh, lecture. So I hope this gives you an exhaustive, not exhaustive, but a very good idea of how communication protocols work, what are the different communication protocols, why they are needed, things like these. So yeah, thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.